Imagine you are an ancient builder. You need to make a perfect right angle, but you don't have a calculator, no smartphone, no laser level, not even a ruler with modern measurements. So how do you know your angle is exactly 90 degrees? Thousands of years ago, people faced this problem. And somewhere in the ancient world, mathematicians discovered something astonishing. If you know two sides of a right triangle, you can determine the third. Today, we know it as the Pythagorean theorem. But here's the mystery. Did Pythagoras actually discover it? To understand the story, we need to travel back more than 2,000 years. Long before Pythagoras was born, ancient civilizations were already using right triangles. Egyptian builders needed accurate right angles to construct buildings, temples, and pyramids. One clever method used a rope divided into equal sections. Imagine a rope with 12 equally spaced points. Builders could arrange it into a triangle with sides measuring 3, 4, and 5. When the rope was pulled tight, the angle between the 3-unit and 4-unit sides becomes exactly 90 degrees. The triangle was a perfect right triangle. But there was something deeper hiding inside those numbers.
The square built on the side of length 3 has an area of 3 times 3 equals 9. The square on the side of length 4 has 4 times 4 equals 16. And the square on the longest side has 5 times 5 equals 25. Now add the first two. 9 plus 16 equals 25. The two smaller squares have exactly the same total area as the largest square. And this wasn't a coincidence. It worked for every right triangle. Around the 6th century BCE, a Greek philosopher and mathematician named Pythagoras became fascinated by mathematics, geometry, music, and the patterns hidden in nature. He founded a mathematical community in southern Italy known as the Pythagorean school. For the Pythagoreans, numbers weren't simply tools for calculation. They believed numbers revealed the hidden order of the universe, and right triangles offered one of the clearest examples of that hidden order. But there's an important twist.
Despite what the name suggests, we don't actually know whether Pythagoras was the first person to discover the relationship. Evidence suggests that Babylonian mathematicians knew examples of right triangle relationships centuries before Pythagoras. The famous Babylonian tablet known as Plimpton 322, created long before Pythagoras, contains numerical relationships associated with right triangles. So why do we call it the Pythagorean theorem? Because Pythagoras and his mathematical school are traditionally credited with developing or proving the general geometric relationship. In other words, the story may not be about one man suddenly inventing an equation. It may be about humanity gradually uncovering a pattern that nature had been using all along. Here's where the real mathematical breakthrough happens. Instead of saying 3 squared plus 4 squared equals 5 squared, we can describe every possible right triangle. Let the two shorter sides be A and B, and let the longest side, the side opposite the right angle, be C. Then something remarkable happens.
The area of the square on side A plus the area of the square on side B equals the area of the square on side C. That gives us the famous relationship: A squared plus B squared equals C squared. Finding one example isn't enough. A mathematician wants to know, why does it always work? That's where proof enters mathematics. A proof doesn't simply say, look, it worked 3 times. A proof explains why it must work every time. Over history, mathematicians developed many different proofs of the Pythagorean theorem. Some use rearrangement, some use similar triangles, some use algebra, and some use elegant geometric constructions. The remarkable thing is that completely different paths can lead to the same truth. But here's the most beautiful part. Pythagoras didn't create this relationship. Humans didn't create it. The relationship was already there, before mathematics, before Greece, before Egypt, before humans could write, right triangles existed. Whenever something moves through two perpendicular directions, geometry connects those movements. Move 3 units in one direction, then 4 units in another, and the direct distance between the starting point and the final point is 5. Nature doesn't need to calculate it. The geometry simply happens. And that ancient relationship didn't stay inside Greek geometry. Today, the Pythagorean theorem appears everywhere. Architects use it, engineers use it, computer graphics use it, robotics uses it, navigation uses it, physics uses it. Even your smartphone can perform millions of calculations based on geometric relationships like this. A theorem discovered, or perhaps proved, thousands of years ago still helps machines understand distance and space today.
So, did Pythagoras really discover his famous theorem? Maybe. Maybe someone before him discovered the pattern. Maybe Pythagoras helped turn an ancient observation into a mathematical proof. But perhaps the bigger story is something else. Mathematics is not always about inventing the rules. Sometimes it's about discovering the rules that nature has been following all along. And the Pythagorean theorem is one of the clearest examples. A simple triangle, 3 sides, 1 right angle, and a relationship powerful enough to connect ancient builders to modern technology. Thousands of years ago, someone looked at a right triangle and realized there was a secret hiding inside it. We still use that secret today. A squared plus b squared equals c squared. And that's the story behind one of the most famous equations in mathematics.
PhyTure Channel, where physics meets nature.